So the absolute value, all I'm going to ask you to do is do your chart in shade. So my vertex is 2, -7. Okay? When I plug 2 in for my x, I'm sorry, not 2 in for my x, I need to go 1 and 3. So let's plug 3 in for our x. 3 minus 2 minus 7. The absolute value of 1 is 1. So 3 times 1 is 3. And it's -4. So this number is -4 and this number is -4. Now, when it's a less than sign, once I put my 3 points in, 2 -7, 1 -4, 3 -4, it's a dotted line. Okay? Now, when you go to shade, I'm a big fan of using 0, 0. If 0, 0 is true, you shade where the 0, 0 is. If 0, 0 is false, you shade away from the 0, 0. So in this case, 0 is less than 3, 0 minus 2, minus 7. The absolute value of -2 is 2. And 6 minus 7 is a -1. Okay, I kind of skipped a step there. 3 times 2 is 6. 6 minus 7 is -1. 0 is less than -1. True or false? That's false. So we shade where the 0, 0 is not. We shade outside the V. Pick a point. 9, 0. 9, 0 should create a true statement. 9 minus 2 is 7. The absolute value of 7 is 7. 7 times 3 is 21. 21 minus 7 is 14. So when x is 9, this side on the right is 14. Is 0 less than 14? That's true. Therefore, your shaded region is good. You shade where the 0, 0 is not when it makes it false. You shade where the 0, 0 is when it makes it true. Second one here. My vertex is -4, 5. It's whatever makes the absolute value equal to 0. That has been consistent throughout every single problem. Because the fraction in front is -1/2 as the denominator of 2, I'm going to count down by 2, I'm going to count up by 2. So when I plug a 2 in, or a -2 in, I'll use -1/2, absolute value -2 plus 4 plus 5. -1/2, the absolute value of 2 plus 5. -1/2 times 2 plus 5, -1 plus 5, and that's 4. So my graph, -4, -5, -6, -4, -2, -6, 4, -2, 4. Greater than or equal to, it's a solid line. The 0, 0 is clearly inside that V. When I plug 0, 0 in, 0 is greater than -1/2, 0 plus 4 plus 5. 0 plus 4 is 4. The absolute value of 4 is 4. 4 times -1/2 is -2. -2 plus 5 is 3. That is a false statement. 0 is not greater than 3. So we're going to shade away. Pick any point you'd like to check it. 4, 5. 4 plus 4 is 8. Absolute value of 8 is 8. 8 times -1/2 is -4. -4 plus 5 is 1. And 5 is greater than 1, so this point makes a true statement. If 1 point in the shaded region makes a true statement, we should be good across the board. So with parabolas, same deal. My vertex is 5, 9. Since the number in front of the parenthesis is a positive or is a negative whole number, as long as it's whole, we're counting by 1. So I'm going to go down 1, 4, up 1, 6. I'll plug 4 in. Negative 2, 4 minus 5 squared plus 9. 4 minus 5 is a negative 1. You've got to do the square first. Negative 1 squared is 1. That turns it positive. So now we're at negative 2 plus 9. So it's 7. So 5, 9, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 6, 7, and 4, 7. If you want that extra point, you can plug 7 in. 7 minus 5 is 2, 2 squared is 4, 4 times negative 2 is negative 8. Negative 8 plus 9 is 1. And when we can go the other way as well here. Okay? This is a solid line. My point 0, 0 is right here. 0 is less than or equal to negative 2, 0 minus 5 squared plus 9. When you do that math, negative 5 squared is 25, times negative 2 is negative 50, plus 9 we get negative 41. That's false. Therefore, we shade where the 0, 0 is not. Since 0, 0 creates a false statement, it's not inside the parabola, we're shading inside the parabola. So my vertex is going to be negative 1, negative 8. Since my denominator is 2, I'm going to count down by 2, I'm going to count up by 2. 3 halves. Negative 3 plus 1 squared minus 8. 3 halves. Negative 2 squared minus 8. Negative 2 squared is a 4 minus 8. 3 halves times 4 is 6 minus 8, and we get a negative 2. So I get a negative 2 here and a negative 2 here. So, negative 1, negative 8 is right here. 1, negative 2 is right here. Negative 3, 2 is right here. It's a dotted line where the 0, 0 is clearly inside the parabola. 0 is greater than 3 halves. 0 plus 1 squared minus 8. 3 halves, 1 squared minus 8. 3 halves times 1. 3 halves minus 8. And we get negative 6.5. That's a true statement. 0 is greater than 6.5. So we shade where the 0, 0 is, which is inside. So with these, I'm just making the judgment off of where x is. If my x is negative 3, that's less than negative 2. So I use the negative x is less than or equal to negative 2 expression, 3x minus 2. So 3 times negative 3 minus 2 is a negative 11. Negative 2 is less than or equal to negative 2. So 3 times negative 2 minus 2 is negative 8. 1 is greater than negative 2. So negative 2 times 1 plus 3 is 1. I'm plugging my x into the expression that goes where x makes it true. Negative 3 is less than negative 2, so I plug the x into this expression. Negative 2 is less than or equal to negative 2, I plug it into this expression. 1 is greater than negative 2, so we plug it into this expression. Same deal here. Negative 8 is less than negative 4. So negative 3 halves times negative 8 plus 3. A negative times a negative is a positive. 8 divided by 2 is 4. 4 times 3 is 12. So 12 plus 3 is 15. Then negative 4 is greater than or equal to negative 4. So it's 5 halves times negative 4 minus 2. Negative 4 times 5 halves is negative 10. Minus 2 is negative 12. And then negative 2 is greater than or equal to negative 4. So 5 halves times a negative 2 minus 2 5 halves times negative 2 is negative 5.
And negative 5 minus 2 is negative 7.
And those are my answers. Pretty straightforward.